here's our game plan when we're in 6-4. The very first direction I want to make really clear. When it says draw a rough sketch of each function, rough sketch means maybe type it into the graphing calculator and get some points from a table maybe. It doesn't mean just like I won't even be able to recognize it because you're just scribbling something down. So oops, so do be cautious. Get it typed in. If you want to get an idea of what it looks like at first, since you probably won't know this off the top of your head, you can go ahead and hit graph and get an idea of the funky picture you're going to get. But again, don't just sketch this at that point because you need a little bit of accuracy for some of the information you're going to get. So again, what I would do is I would go back to the table and I would find any point that would fit on my graph and I would plot those to kind of give me some work. Now, negative 224 is not going to fit. Negative 1, negative 7 is, though. And so is 0, negative 8. And so is 1, negative 3. And so is 2, 8. And 3, 1. Now, if that still doesn't give you quite enough info, now that you have some points plotted, actually, now if you want to go back and look, so you can kind of guesstimate, be like, okay, so it's like, and get myself kind of close. There's nothing wrong with that. So you're like, ooh, that's kind of weird. And it is. So once I get those points up, now the one thing I believe that may be a little bit new to play with is this thing called turning points, and it's exactly what it is. A turning point just means my graph is going one direction and all of a sudden it changes and starts going another direction. So in our case here, I'm going up and then, wait a minute, oops, I'm starting to go down. This would be one turning point. So then I'm going down, whoops, now I'm starting to go up. This would be a turning point. I'm going up, and then all of a sudden I get to the top, whoops, now I'm going back down. So in this case, I've got 3 turning points. I need to know what those values are. Now the only way to be sure of what those values are, since I don't know every single point on here, is to use my experience with maxes and mins, which is going to also help me out with some of these. So when I'm looking at my turning points, I'm going to go ahead, I'm going to hit second trace, and then we're going to go back to this calculate menu that we've literally lived off of for a lot of our graphing purposes. So this first one I've got here that's going up and then coming back down looks like a max because it has that hill shape to it. So I'm going to go ahead, I'm going to get maximum. And like we did before, my cursor, my idea is I'm trying to trap this point. So my blinky guy here, my cursor's got to be to the left. As soon as I see he's to the left, I'm going to hit enter. Then I'm going to bring him back over here somewhere to the right. Okay, my point's over here. So he's fine there. And I'm just going to hit enter twice. And whatever values I get, and we're just going to go to the nearest hundredths. We're going to go to 2 decimal places. So I have a turning point. Let's see here. Oh, the number of turning points. Oh, Harty. I'm making this too complicated. That's why my max and min's down here. Silly man. But since I already have this max, I'm going to write it down. Negative 0.86. Negative 6.86. Okay. I apologize. Yeah, turning points, we're just looking for a number. How many of them there are. Because otherwise we're being repetitive with our maxes and mins. So we've got our turning points. Yes, sir. It absolutely would. I appreciate that, sir. I went into rounding mode and I had no business rounding. Negative 0.85. Thank you. So then, as I work my way down, my end behavior, remember, that's when we've got our f of x is approaching negative infinity or infinity. As x approaches And with my x's, one will always be negative infinity. One will continue to always be positive infinity. So I have to take a peek at what's going on. And just kind of as a reminder, and sometimes this helps people and sometimes they're like, no, I really don't need you to do that. But as I look at them, I like to kind of look at them as far as the pictures are going. So as x is heading towards negative infinity, and that's over here furthest to the left, is my graph heading towards positive or negative infinity? Negative, because this represents my x's. So I'm heading down towards negative infinity. When I start heading the other way, when I'm getting over here to where my graph is furthest to the right, I still am heading down, down, down. So I'm also heading towards negative infinity. Note the word end on end behavior. It's the ends of my graph. Wherever the arrows are, that's where I'm trying to determine what direction I'm heading. So that's how I'll do those. Odd or even just asks what the function is. So here, I have a 4th degree function. Last time I checked, 4 would be an even number. So that's how I can determine which way that's going to be going. Zeros, remember, are just a fancy way of saying x-intercepts. So I look and I'm like, I see 2 of them. There's one here and one here. So I need to find those. So like we did before, back to the calculate menu, we want a 0. We're going to trap it. So bring my cursor guy over. My left bound needs to be a little bit to the left of it. Anywhere down here would be fine. Hit my enter. Right, anywhere above it, because I'm trapping it in between. And I'll just hit enter twice. So I've got a 0 at 1.270. And then I still got to find this other one over here to the right. So I've got to move my way around. Now this time, remember, since I'm heading down, my left bound will be above the line this time. And if I reverse them on accident, it's going to give me an error message. So it's not like I'll get a wrong answer. I just won't get any answer at all. So above here on my left, and I'm still heading to the right. And then below here, and that traps it in. And so my other one would be at 3.03. And again, don't let the funky language on y mess you up. Negative 2e to the negative 12th is so close to 0 that it would round to it anyway. It just means it's 0.00000000002. So that's pretty close to 0. So that would get me my zeros. Max, I found 1. Is that the only one? No. We found this guy. We still need to find this one. So one more job with our maxes here. Let me get back over on this side. So I'm on the left side of my point over here. Then I come to the right. Anywhere to the right is fine. 2 enters. And I've got another max at 2.35, 9.55. And I visually see, okay, there's a max there, there's another max down there. Minimum, maximum, maximum, and there's my 3rd turning point. So for the number of turning points you have, you should have that number of maxes and mins total. So since I have 3 turning points, I have 2 maxes and 1 min. So it's this little dip down here at the bottom. So anywhere to the left of that's fine. Then we get to the right of the dip with a couple of enters. And we've got a minimum of 6.70. Oops, not 0. Harty. Jeez. -8. Losing my mind.
The x be a 0 because it's got the e at the end.
Hang on, this needs to be on video. Okay. Needs to be on video.
I caused a face palm.
0, -8. We'll get there yet.
That won't work. Try graphing.
Oh dear. Okay. That is a minimum of 0, -8. I have it written right here. I still pay no attention to it. Okay. Domain and range. Not even I can mess this up at this point. What is domain always going to be? Negative infinity to infinity. When I get the double arrows going, that's going to be the case. My range, though. Since it goes bottom to top, bottom keeps going forever. Okay, that's negative infinity. Where's my max at? And here's the perfect reason why when we talk about sketches, we can't necessarily go right off of the sketch. When we plotted our points and I made my sketch, that was before I'd done my max value on this. If I just did it based on my sketch, you're right. I'd look at that and say it's at 8. But when I did my actual max, I found the actual max value, which is at 9.55, which makes me think, when we're doing this, would it be wiser for us to wait until we've found all this information to make our sketch? I think so. So let's do that on this next one and see if we end up more accurate. Sometimes seeing where things can cause an issue can help us to be better when it comes to the next one. So let's see what happens on this next one. All right. Now I'm going to get an idea of what it looks like. Parabola, because it's a quadratic. Okay. Now, before this time I get into all the other funny business, I'm just going to look at that picture for right now. How many turning points do I have? 1, because it comes down here and then it heads back up. Okay, so 1. What about my end behavior? Because remember, I'm always going to have x to the left and x to the right with positive and negative infinity. As my graph is going to the left, what's happening to the y value? Up towards infinity and right. Since they're heading up on both directions, both up to the left and up to the right, those are both going to be infinity. Odd or even function? Even. Because again, we're looking with a quadratic. Looks like we have 2 zeros. So let's find those next. Again, left of my point, right of my point. So 0.7190 is my first one here. Then it looks like I got one more over here. So to the left of my point, to the right, and 2.780. Okay, and I see there was only 2 of those, so I'm good there. Do I have a max this time? No. I see no hills, I only see valleys. So my min's down here somewhere, so let's find it. Trap that min in down there. 1.75, negative 2.13. And then my domain and range based on my information. Well, again, domain's the easy one. Range. bottom to top. Yes, sir.
Negative 2.13 to infinity.
There you go. And now I think we have more than enough information to be able to start doing a little bit of sketching here. I still would plot my points that I can get off of here, but now I also have some points that are available to me. Maybe at my zeros here. Oops. To give myself a little more accurate of a parabola. Let's do one more that might throw kind of a weird look at us here. Let's play with 3. Swing this guy over so some of you that are still jotting things can. And we'll take a look at this guy on the right. And then we'll take a peek at how we're going to work this. All right, let's see. All right, that doesn't look too terribly awful to deal with. How many turning points do we have this time? 2. One here and one down here. So 2 of those. Okay, my end behavior. Again, x to negative and to positive infinity. So as x heads to the left towards negative infinity, where is my f of x or my y heading? Down. So we're heading to negative infinity there. But as my graph heads off to the right to positive infinity, we're heading up. Okay, we have an odd or even degreed function this time. Odd because my degree is 3. Oh, disappeared. Zeros, it looks like we only got one of them this time. So that shouldn't take long to find. Again, anywhere below, that's going to be to the left here. In this case, then, anywhere above would be to the right. So 3.810 would give me that one. Maximum, I see one hill. So again, anywhere to the left of it, anywhere to the right. So we're at 0.13, negative 0.94. That gets me that guy. I got 1 min, and again, that makes sense. 2 turning points, 1 max, 1 min. That adds up to 2. Again, anywhere over here to the left with your cursor is fine. And a couple of enters there. 2.54, negative 7.88. And then we just got to deal with domain, which is always the same. What about my range this time? Nice, because it goes forever down and forever up, going each way, so it's negative infinity to infinity. So again, get myself some points to work with. Negative 1, negative 7, 0, negative 1, negative 3, 2, negative 7, 3, negative 7, 4, 3. And then our other points we have, so we have a 0 right there. just do something goofy? No. Negative 1.3. Get that in, 2.5. 7.88, and then we'll take a look at the picture again so we can be accurate here. So what we're going to do with this this will be homework check 12, assignment number 2. And tomorrow there will be a worksheet that kind of goes along with this to get you a little more practice and also to give you some time to work in class if you need to, since again this is kind of dependent on a graphing calculator. Then Monday we'll get back into some of the regular stuff here and keep popping our way along.